Hello everyone, this is Toufiq Hossain. I'm going to present our research paper titled as Boundary Tunable Dynamic Metasurface Antenna for Computational Imaging. So what is computational imaging? On contrary of conventional microwave imaging, the computational microwave imaging use some computational process. So in this case, we use normally random beam patterns to interrogate the sparse scene information, and then these random measurements are processed by some algorithms developed by computer science community, and then we get the image of the scene. So the whole imaging equation can be represented as this simple form: G is equals HF plus N, where H is the measurement matrix and F is the reflectivity of the scene and D is the collection of the measurements. Now the goal here is to diversify the measurements captured in the H matrix, and how diverse is those measurements that can be depicted by the singular value decomposition of this H matrix. And the second goal is represented as to increase those diverse measurements, the number of those diverse measurements, to get a good imaging to be done. Different approach has been proposed in previous literatures, which include a frequency tunable approach and some sort, and another one is dynamic tunable approach. And in dynamic tunable approach, there has been a proposed some sort of cavity based approach in which the boundary is tuned, but those are normally in bulky in size and very big size antenna. So our approach is not using some sort of cavity based approach, but our approach is a planar approach, and then boundary is tuned as done in cavity based approach of dynamic tunable approach. So here we are using some sort of combination of PEC and PMC for the proof of concept demonstration of this novel approach. And by using this PEC and PMC combination, we can generate different diverse beams even in single frequency. And if we are using multiple frequencies, then we are getting more number of diverse beams, and which is depicted here. If we are using just frequency tunable approach, fixing the boundary, then frequency tunable approach is not giving us some different diverse beams. Rather, there are some sort of redundant information collected by these overlapped beams, which is shown as the black dotted circle. Now, if we are using boundary tunable approach, even in single frequency, we can get different diverse beams, which is depicted also in the singular value decomposition. And as the singular value decomposition of the red is showing more flatter curve, that means the measurements are less correlated and they are more diverse. So this is the novelty of our structure. Thank you for bearing with us.